All right, so we're going to talk about stem and leaf plots, sometimes known as stem plots. So this is a way of displaying numerical data, which gives us a little bit of an idea of the shape of the distribution of the data and preserves the individual values for each data point. So let's say we have this kind of small data set here, and it looks like 2, 4, 6, 8, 10, 12, 13 values in this data set. I have arranged these values in ascending order, so low value of 9 and a high value of 50. So now if you're asked to create a stem plot or a stem and leaf plot of this data, since all these values are 2 digits, we're going to let the stems be the tens digit. The leaves are generally going to be the last significant digit in the values in the data set. So if it's 2 digits, the units digit is the last significant digit. If it's 3 digits, like if we had this data set here with numbers that have 3 digits in them, then we use the hundreds and tens digits as the stems, and the last significant digit is the leaf or the leaves. Okay, so looking at this data set here, again, we have, what did I say, 2, 4, 6, 8, 10, 12, 13 values. You can either put these stems in descending order or ascending, in this case, ascending order or descending order. It doesn't really matter. Just put them in some order. So we have values ranging from 0, 9 to 50, 5, 0. So our stems consist of 0, 10s, 20s, 30s, 40s, and 50s. Each leaf represents one of the data points. So the value of 9 is a stem of 0 and a leaf of 9. And we have an 11, stem of 10, leaf of 11, 13, stem of 10, leaf of 3, 15, stem of 10, leaf of 5. So this is how we create a stem and leaf plot. You put the values here in ascending order as far as you need to go. We have 22, stem of 10, unit of 2, leaf is 2, 27, 33, 37, 41, 42, 43, 44, and 50. So this is a representation of this data set. So notice what this tells us. It kind of gives us an idea of how spread out the data is. And realize here also that if we create bars here, we kind of get the same information that we get from a bar graph or a histogram that we would, except in this case, we also preserve the individual values, right? So the stem and leaf plot gives us all the information that a histogram does, but it also preserves the individual values. Like in a bar graph or a histogram, we wouldn't see the individual values, we would just get the height. So if you turn this 90 degrees this way, we get the same information as we would from a bar graph. So a couple other ideas for stem plots. Like we said, if it's more than 2 digits, or if there's some 2 digits and some 3 digits, we have to kind of look at the data to determine what the stems and what the leaves are going to consist of. For 3 digits, like we said, the last significant digit constitutes the leaves. So in this case, 102 would have a stem of 10 and a leaf of 2. 111, a stem of 11. 110 and 1 to get the 111. 121, 122, 125. There is no values in the 130s, but we put it there as a placeholder. And then 140, we get the 1 and the 4 as the stem and the 0 as the leaf. All right. So one last thing on stem and leaf plots. Once in a while, if you have a data set that looks something like this, where all the values are between 11 and 29, so if we just use 1 and 2 as the stems, we're not going to get a lot of information about how spread out the data is. So sometimes we use something called split stems. since we have all these values in the tens, right, from 11 to 17, we can split the tens into two parts, right? So we'll have the values 10 through 14 in our first stem, and the values 15 through 19 in our second stem. Similarly, for the 20s, we'll split up the 20s into 20 to 24 and 25 to 29. So this is an example of split stems. Again, it gives us a little bit more idea of the data. If we just used a 1 and 2, we just have two long lines, and it wouldn't give us a lot of information. All right, so that is how to create a stem and leaf plot. All right, see you next time.